Hello everyone. In today's video, we'll talk about imbalanced data, right? So let's jump into the topic. So imbalanced data is one of the major problem for the classification world, right? So first of all, right, we'll try to understand why we'll have imbalanced data. Let's say, I have 100 customers who is holding a credit card. Maybe maximum I may have 2 or 3% the defaulters, right? And the remaining 95 to 97% the perfect payers. So this is called a presence of minority, right? So now if I run any machine learning algorithm for predict the customer behavior, like whether the customer is a defaulter or non-defaulter, right? So we may not be able to predict correctly because our model will be trained well with the majority of the classes, right? Because here in our case, 95 to 97% customers are good. They are non-defaulters, right? So it might predict the majority classes very well, but not the minority classes because we have only few percentage of the minority classes. This will leads to biased prediction on misleading the accuracy in the classification world, right? So now how will we overcome this problem? So we have below two options. First, we need to reduce the observation related to the majority classes. Let's say out of 75 to 95 to 97 percentage, of the good customers, we need to reduce them in our case, or else we need to increase the size of observation related to the minority classes. Which the first technique we call it undersampling because we are reducing the number of observations. The second technique we call it oversampling because we are increasing the samples of the minority classes. So which option would you prefer? So if I go for undersampling, right? So which means like I'll be deleting lot of the data, the real data, right? So which means we are losing the lots of valuable information. In my opinion, the oversampling is the best option because we are not deleting any real data. What we are doing is we are adding some new data. And how we add the new data, there might be many options. We can randomly add the new data which belongs to the minority classes, or else we can copy paste. If I do copy paste, that may become the duplicated record. There must be some technique that resemble the real data, right? So in my opinion, right, my experience, I would always prefer smoothie. That is one of the best, for the oversampling technique. And another important thing which we need to remember here is, so it's not like whenever I have, the minority classes, I simply need to, oversample it. No, even if I have a minority sample, better we'll try with, the different options, fine tuning parameter of a machine learning algorithms and see if our model is working fine. If not, then we should go for oversampling and try different techniques, right? So we'll try to understand the smoothie here, right? So smoothie is nothing but synthetic minority oversampling technique, right? This internally uses k-nearest neighbor algorithm. You may not understand how it works, but in our upcoming videos, we'll see how k-nearest neighbor algorithm works, right? So let's say in our case we have four minor samples which I need to oversample it, right? First we need to identify the future vectors and its nearest neighbor. So right, so these are the two future vectors, and now uh, take the difference between two data points, right? Difference between these two data points. We already identified the future vector, right? And add the difference with any random number between 0 to 1, right? So now identify a new point on this line by adding the random number to the future vector, right? So now this is one of our oversampling, right? Which we made. We need to repeat it as many times as we want. Let's say if I want 10 minority oversampling, so I have 4. I need 6 more, total 10. In that case, I need to repeat this step 6 times, right? So maybe if you don't understand what are the steps which we see now, in very simple, right? So it draws a line between existing minority classes. If you see it, right, the non-red colors, I draw the lines, right? And then it imagines, right, the new instance somewhere on those lines. Got it? So it draws the lines on the existing data points, and on that lines, it will imagine some data points, right? And it will cook the data. That's how Smoothie works in a very layman, right? So there are two important parameters in Smoothie, anyways, that we are going to cover in our upcoming videos. The one is the Smoothie percentage, right? So that's like how many minority observations I need to add. In our above example, we had four bad customers, right? If I say Smoothie percentage 100, then adding the same number of minority classes. Let's say if I say 100, so it will add four more minority classes. As I have four minority classes. If I say 200, it will add double that, right? So the another parameter is number of nearest neighbor. This is one of the fine-tuned parameter for KNN algorithm, which is k nearest neighbor. K is nothing but number of nearest neighbors. I mean K is nothing but the integer that says how many nearest neighbors I need, right? So by increasing the number of nearest neighbor, which is nothing but k, right? In k nearest neighbor k, you get features from more cases. By keeping the number of nearest neighbor low, you use features that are more like those in the original samples, right? Anyways, as I said, right? So in our upcoming videos, we'll try to understand how this k nearest neighbor works behind the screens, and also we'll see how this how we'll also use Smoothie in our upcoming videos. So hope you enjoyed this video. In our next video, we will take some the classification data and try to apply the logistic regression. We'll make sure we'll have a imbalance data so that we can also apply this Smoothie technique there. So till then, please subscribe my channel. Stay tuned. Thank you.